Good evening, everyone. My name is Masaki Fukui. Thanks for having me today. Well, it's been a really long day for me. My flight from Japan got canceled, but I managed to get here. So it's fortunately. Our work is titled, it's about a tool we created, Tataki enhancing the robustness of bioinformatics workflows with simple tolerant file format detection. This project was conducted by myself and my co-authors Hirotaka and Tazuro. First of all, what is Tataki? Tataki just tells you the actual format of a file. Simple as it is. But why file formats? Is it important to correctly identify file formats? Well, that's because in the context of a workflow, software misidentifying file formats might degrade robustness of workflow. Here you see an illustration workflow graph. It's not 100% certain that every software in the graph outputs files in the expected format. And this makes that every software in workflow has the risk of terminating abnormally. Debugging becomes difficult when a lot of workflows fail, and it is going to be a waste of resources when long-running workflows fail. You probably want workflows to be more robust. This is when Tataki comes into play. Tataki verifies file format and improves robustness of workflow run. There are some ways of applying Tataki into workflow. It's either by executing Tataki in between all tools, executing Tataki when the workflow fails for easier debugging, and applying it to a final output for recording the provenance. And next, let me show you the Tataki execution sample. File whose SAM is definitely a SAM file. Tataki tells you that it is a SAM file by showing you in the ontology information, which is a community standard. And what about this one? Most definitely a BET file. No, this is not actually a BET file. It is a mixture of BET and FASTQ format. Who would guess? It's surprisingly. Tataki won't be tricked by the file extension and verifies the actual file format of a file. This literally is one of the cases where Tataki is useful. Next, I will present design philosophy of Tataki and the details of it. We wanted Tataki to be used within workflows and simple, intuitive to use, and last is about contributability. We wanted to make it easier for developers to contribute to Tataki, which makes Tataki more extendable and flexible. Let's have a closer look. Tataki has two modes of file detection, and this slide is about the first one, default one, which is implemented in Rust. Tataki utilizes library called noodles as a main file format checker, which is a specification compliant parser. And also by default, Tataki checks only the first n records for saving time. If you want a more thorough format check and don't mind it taking a longer time, you can use a tidy option to check the entire content of a file. As for the format coverage, it supports major bioinformatics formats, as you can see in the screenshot. As you may have noticed that each file extension is implemented in its own separate file, we designed this and surrounding ecosystem for easy module addition, so that developers can focus on adding their specific parser algorithms. If you can write in Rust, you're welcome to contribute algorithms to increase tool format coverage. Next is about second execution mode, which uses CWL tool definition. Developers can create a CWL document, like shown here in the left, and can use it as a format identification criteria. This example here is using a SAM tools view as a format identification criteria for identifying SAM file. What's so useful about this is that you can reuse existing analytical tools as a parser. So these are the two ways that makes Tataki more contributable. And by utilizing these two modes together, Tataki can become so extendable that have potential to handle new file formats in the future and file formats with inconsistencies. Finally, let's quickly go over some additional features. Tataki outputs item ontology identifier with its label. So you can select output format from CSV, TSV, YAML, JSON by command line option. It provides OCI container, and last but not least, it provides single binary in 2 formats. Thank you.